So this is a selection of problems from Mole Worksheet 1. I'm going to do one from each section so you can see kind of the process for each type, because there's basically 4 main types and then a couple of multi-step problems at the end. So this first section, you are going to convert from moles into grams. Okay, so the general form for converting moles into grams is you always start with your given, and whenever you see grams, you should be thinking periodic table, because the molar mass in grams is found on the periodic table. So you're going to take the given, and then you're going to multiply it by the molar mass, which is on the periodic table. Again, it's the same number as the average atomic mass, but it's in grams because we're talking about a mole. And so the molar mass is the mass of 1 mole of whatever it is you're talking about. So if you multiply those, you get the new mass in grams. So for this one, I'm going to do number 2 right there, just as the example. So our given is 2.20 moles of tin. And then we're going to multiply that by the molar mass of tin from the periodic table, which is 118.71. And when we multiply that, we get 261 grams of tin. It's important, number one, that you try to think about significant figures when you're doing this. Our 2.20 moles of tin only has 3 significant figures, so our answer, 261, only has 3 significant figures. Just do your best to try to keep a consistent number of digits when you're doing this. The other thing that's important is that when you label, you want to label with both the units, grams, and the identity of the element or compound that you're talking about. That's going to become more important as we move through this year. So do that. So the second section of problems is converting from number of atoms to moles. You know that regardless of the identity of the element, there are always 6.02 times 10 to the 23rd atoms or molecules or formula units or whatever per mole. So we're going to use, in this case, Avogadro's number. So the generic form, we are going to take the given, which in this case is atoms. You could also be dealing with particles, molecules, or something. And then we're going to multiply that by 1 mole. So is what you want. So you want moles, so that goes on top, over Avogadro's number. So that will give your answer in moles. Okay, so I'm going to do number 6. So we have 12.04 times 10 to the 23rd atoms of helium. It doesn't matter what type of atoms they are for the math, because 1 mole of anything is always 6.02 times 10 to the 23rd. So we're going to take that, 1 mole over 6.02 times 10 to the 23rd atoms. So atoms cancel, and we are left with 2 moles of helium. Okay, so when you're dealing with grams, you want to make sure you're using the molar mass. When you're dealing with atoms and particles, you want to make sure you're using Avogadro's number. Okay, so the next set, we're back to grams. This time we're going the opposite direction from grams to moles. So in this case, it's just going to be the reverse, the inverse, I guess, of the first set of problems. So this time we're going to take the given, and we are going to so our given in this case is grams. We're going to multiply that by 1 mole over the molar mass, because this time we want to end up with moles. So that will give us our answer in moles. For this one, I'm going to do number 12. I just want to point out for tin to chloride, you're going to take the mass of the tin plus the mass of 2 chlorides to get the molar mass. So you're still looking at the periodic table. You're just adding up all of the parts of the ionic compound. So we're given 59.3 grams. And then our 1 mole over the molar mass, which 10 plus 2 chlorides is 189.61. So grams cancel, and we get 0.313 moles of tin to chloride. Okay, so the important thing here is just make sure that you're getting the correct molar mass. You're adding up all of the parts, and then whatever you want to end up with as your units, that's going to go on the top of your conversion factor. And again, trying to mind significant figures, not having an absurd quantity of decimal places. This next section is the opposite, or the inverse of the second section. So this time we're going from moles to particles. So this time, notice there are particles that are atoms. Argon's just an atom. Iron 2 sulfate is a formula unit because it's a part of an ionic compound. If there was H2O, water, the particle would be a molecule. So you just correspond your label to whatever type of particle you're dealing with. So since we're just dealing with moles and particles, we don't need to do anything with grams in this case. So you just have your given moles, and then since we want particles, we put particles on the top. And then we put 1 mole on the bottom. So that will give us our answer in particles. So I'm going to do number 17. So we have our given moles is 8.5 of iron 2 sulfate. 1 mole of anything, doesn't matter what, is 6.02 times 10 to the 23rd particles. So moles will cancel. And then we'll get, again, paying kind of attention to sig figs, we're going to get 5.1 times 10 to the 24th particles. And in this case, since we're looking at iron 2 sulfate, which is an ionic compound, our type of particle specifically is going to be formula units. If we had done 16 and we were talking about argon, it would be atoms. If we had done a different one and it was a covalent compound, it would be molecules. Okay. And the next two sections are two-step problems. So you need to do two of the conversions that we just did and put them together. You have a couple of options as to how you want to approach this. You can do the conversion separately, or you can sort of clump them all together into one longer problem. The key thing to remember is that, for instance, here you want to go from atoms or particles to mass in grams, and there's no sort of direct path from atoms to mass in grams. So you need to go from atoms or particles to moles and then to grams. So moles is always the sort of in-between step that allows you to get from one type of counting to another. So in this case, we're starting with atoms or particles. So the first conversion you'll need to do is from atoms or particles to moles. So you have your given, and then 1 mole is always 6.02 times 10 to the 23rd atoms. And you could stop here, hit equals, get an answer, and then use that answer to do your moles to grams conversion. The other thing you could do is that you could take this and just keep adding to the conversion. Okay, so this will, the atoms will cancel, we'll have moles. So then we could add, since we have moles on the top and we want grams, we could add molar mass over 1 mole. Moles will cancel and we'll be left with grams. So you can put the parts of the conversion together, or you can do them separately. Do the first one, atoms to moles, solve that, and then use that answer to go from moles to grams. So for this one, I'm going to do number 22. Right there. And so we're looking at atoms of calcium to grams. So we start with it's atoms of calcium. Here we want to get moles. So we have 1 mole for 6.02 times 10 to the 23rd atoms. Okay, and so at this point, you could solve that and then use that answer to do the next phase. Or, so here you could solve this and then use that to set up your next problem to get from moles to grams, or you can keep adding to this. So then you would take, if you're adding, you would take the molar mass, which for calcium is 40, per 1 mole, and solve that, and that will give you 8 grams of calcium. If you're doing it in 2 steps, you would solve this, and then you would multiply by 40. So it's the same thing, you just have like an equals here, get an answer, and then add that. Either way, it'll work out the same. Okay, last set is here. So this is the inverse of the ones we just did. This time we're going from grams to moles to molecules. And molecules is particles. So it could be atoms if we were going to do 26. It will be molecules because I'm going to do 27 for my example. So water is a molecule. Could be atoms. Again, if we were looking at 28, formula units for 29 and 30. So whatever particles you're dealing with is how you label. So for this one, again, just the opposite of what we did in the last one. So you're given in grams. So we have grams. We think periodic table. 1 mole with a molar mass. So on the periodic table, remember, if it's just an element, you just take that mass from the periodic table. If it's a molecule or a formula unit of an ionic compound, you add up all of the parts to get the total mass. Okay, so grams will cancel, we'll have moles. So again, you could hit equals at that point, get an answer, and then set up the next part of your problem. Or you have moles, so now you're going to need to get to particles. And for particles, we know that it's 6.02 times 10 to the 23rd particles for every 1 mole of whatever, it doesn't matter what. So moles will cancel, and then we'll just be left with our units of particles. So you can separate the purple and the black parts, or you can do them all as one long problem. So here we have, so again I'm going to do 27. So we have 294 grams of water. Okay, so to convert grams to moles, we take the molar mass. The molar mass of oxygen is 16. The molar mass of hydrogen is 1. So 1 times 2 plus 16 is 18. So our grams cancel. So at this point, you could hit equals and then set up the next part of your problem. Or you can keep going and convert to molecules. So what I'm doing, so moles cancel, you're left just with molecules. I'm again trying to pay attention to use significant figures at least a little bit. And so the answer in this case is 9.83 times 10 to the 24th. And in this case, it's molecules because water's smallest part is a molecule. So, this is what the vast majority of the moles problems we'll be doing will look like. Kind of everything in this little video. We will have one other type of conversion to volume, but I want you to be confident about these types of conversions before we talk about that one. So, happy converting.